We'll be covering 4.7 next week then? No, we will be covering 4.7 in the next 20 minutes. That is how 4.7 goes. It's a very short section. Okay, so this was the problem that you guys worked on. I know the last few groups that I got to, they finished the problem, and I didn't have time to loop around to the beginning, that groups 1 and 2, but it looked like groups 1 and 2, they were well on their way to solving the problem. So the final answer was that you needed 80 feet of fencing. That was the final answer, 80 feet of fencing. Okay, so let's actually just very briefly, because it looks like pretty much everyone was getting the problem. Let's very briefly go over the problem, and then we'll go over a problem from 4.7 as well. Okay, so the first thing I noticed in a few of the groups, there was some confusion initially about how should you write the objective function, which groups figured out was the perimeter of this, not really the perimeter, so to speak, actually the total amount of fencing. So like the exterior and interior perimeter of this pen. And one of the confusions in a few groups, some people were giving, say, like L plus 5W. Some people were giving, say, 4L plus 5W. Others were giving other expressions. And people weren't necessarily wrong, but you guys were using different L and W. So make sure that whenever you define variables, especially when you're in a group, you kind of say what they are. Like maybe you could draw them. So for instance, you can see that I've defined my X and Y variables. I'm letting Y be, this vertical length, and X is the horizontal length, but of each individual pen. Some people are letting X, say, be the whole thing, right? The length of all 4 pens at once, which is fine, but just make sure that's clear with your group. Anyone else can hear? My mic is not muted, so if you cannot hear me, let me type this out. Yeah, so sometimes you do have to, in case this ever happens to anyone else in the chat, sometimes when you come back to the breakout rooms, you have to kind of refresh the conference or just leave and come back. So sometimes it just happens like that. All right, anyways, so we have now the perimeter function. So the perimeter was our objective function. So in the variables that I have, it was 4x plus 5y. And then the constraint equation was the fact that each individual pen had to have an area of 80. Okay, so that constraint then was xy equals 80. What is the goal or the role of the constraint equation? The role of the constraint equation is to solve for one variable in terms of the other. Welcome back, Anthony. All right, so I have y equals 80 over x, and then I substitute that into my perimeter function. And I eventually get down to this function here, 4x plus 400 over x. Now keep in mind, your function might have looked a little bit different depending on exactly how you define the length and the width, whether you made the length the whole thing, whether you solve for x in terms of y or y in terms of x. So for instance, you might have also had here like 5x plus 320 over x, depending on what numbers exactly you use, how you defined your variables. But I think I did check on every group, and every group did have the correct function for whatever variables they were using. Okay, so our goal now is to find the absolute minimum value of this function, and the interval in this case is 0 to infinity. I'm allowed to have any positive length for my fence. There's no restrictions on that. Okay, so as usual, I set my first derivative equal to 0. It looked like the first 2 groups I didn't get to see if your algebra was correct, but no matter what your numbers are, the equation should essentially look like this. It should look like a number, a like minus b over x squared equals 0. Every derivative should have looked like that, no matter what numbers you had. And so that reduces, obviously, to x squared equals something, and taking a square root gives you the number, but obviously you don't care about the negative square root. So you either had x equals 10 here, or you had y equals 8, depending on exactly which variable you were using. Okay, now the last thing, which I'm not sure that every group got to, was the justification. So recall that in my example, f prime was 4 minus 400 over x squared. So I know at least 2 groups used the first derivative sign chart to justify that they actually had a local, whatever this was, a minimum, I believe. Yes, minimum such fencing. For us though, I'm just going to use the second derivative. So again, I take the second derivative of this function, and I get 800 over x cubed. And what is important about that, if I'm looking for a minimum, I hope that this is positive, and in fact it is, right? As long as x is positive, my second derivative is also positive. And what does a positive second derivative mean? Positive second derivative means concave up. But always think about that. Always think about it graphically, right? Why does concave up mean a minimum? Right, concave up I know means the function is shaped like a U for up. So clearly that gives me a minimum. And then finally, to get the actual answer, plug your number back into the perimeter function. So I had x equals 10, putting that back into my perimeter function gives me 80 feet.